Shake Table Lab by Finn Meisel and Jared Severance. Jared and I created a building sketch on Sketch. The plan has very useful measurements, such as our tower's height, which is 36 centimeters. The plan has helped Jared and I create our building. When Jared and I started our construction, we decided to build the first 2-story supports. We thought building them would be a good idea because it would be easier to have support set up and ready to support the second story's floor. Although we finished the main structure, we had to support both floors with our extra straws. Jared and I decided to put 4 straws on the bottom because it'll be holding more sandbags. After we had our first and second story supports up, we thought it'd be smart to test the platform. We noticed that the supports that we just put in were not stressed. The next step was to use our extra straws to support our weakest parts on the building. When our building was supported, we had to place paper on the platform so it could hold more sandbags. Our construction sketch was done on Sketch. The sketch has all the measurements on it for the roof, total height, building without the roof, top width, bottom width, and separate stories height. Our final sketch was not the same as our first sketch, such as the total height of the building. We wanted it to be 36 centimeters, but it was 48. My partner and I finally finished our tower, but now we had to test static testing. All 4 of the sandbags were on the tower. We both noticed that the building was not stressing. After we finished testing, we needed to strengthen a few places. Both of us decided to strengthen the platforms. We mostly decided to strengthen the first story because it had the most stress. When Jared and I finished strengthening the tower, that became our strongest part. The platforms are really strong and they are probably our strongest part. Our weakest part is one of the supporters of the second story. But when you follow the straw down, it meets the first story platform, and the straw is horizontal. Therefore, the straw bends and the building collapses. Jared and I decided to use more tape where the main supports are to our building. We also used more tape connecting the building to the bottom because we did not want the building to shake separately from the cardboard. The base of our building is made out of cardboard. Cardboard is a stable surface and will not tip over the building. Together, we both made platforms out of construction paper. The paper will make it easier to place sandbags on it. In the first video, our tower held 4 sandbags, and in the second video, our tower is holding 12 sandbags. Our tower fell on 16, but successfully held 14.
For a minor.
Oh my god. No signs of weakness so far. Oh, I hear very large cracking. Very, very large cracking. Stand forever. Maybe I think I can smell a major earthquake.
See, it's the whole tower right now.
I'm a dog and I smell a major earthquake. Okay.
The XYZ graph shows us the movement of our tower. For example, X is side to side, Y is forward and backwards, and Z is up and down. Our tower moved side to side, which means it had a lot of X movement. Hello, my name is Finn Meisel. Our tower successfully held 14 sandbags. Our weakest part, or where the building collapsed, was our first story X pieces. We put too little tape, and then when the tape came undone, it just collapsed. If I could do this project again, I probably would have added more supports on the sides and more of a cone shape for the middle supports. I learned that it doesn't matter as much about the uprights in the middle as much as it matters about the uprights on the side, because one of our friends' buildings had 0 uprights in the middle and tons on the sides, and it works amazing. I love this project because you get to share your creative mind with all your friends, and it was really fun to build a tower and then destroy it. Thank you.
Hello, my name is Jared Severance.
Our building was relatively strong and held 14 sandbags. The location on our building where it failed was the cross pieces. There was not enough tape holding the cross pieces in place, and the cross pieces came out. At that time, it was almost like there were no supports and the building just collapsed. If I was going to do this building over again, I would make sure we had plenty of tape on the cross pieces so that they wouldn't come out. And I would make sure that most of the supports were diagonal. I learned that an earthquake-proof building has a lot to do about supports. The supports on the sides are very important and that you need plenty of them. The supports in the middle are not as important, but they're still important. I love this project because we got to use our creative mind and we got to learn all about building. Thank you.